limestone, soda ash, metallic oxides, combined with silica sand to transform molten glass into art. Limestone, born beneath ancient oceans, blasted from the quarry, loaded by giant machines, then crushed into fine stone. In glass production, limestone is only about 10% of the batch, but it gives the melt stability. Without it, glass would be weaker against water, weather, and time. Crushed rock, helping sand become glass. Soda ash, a white chemical powder used in modern glass production, processed through massive industrial plants, then transported in enormous quantities every day. In glass manufacturing, soda ash makes up around 15% of the batch mixture. Its role is efficiency. Inside the furnace, it lowers the melting temperature of silica sand, reducing the energy needed to produce molten glass. Without it, glass production would demand far more heat and fuel. Metallic oxides, tiny additives responsible for the color and personality of art glass. Usually making up less than 1% of the entire mixture, yet capable of transforming molten glass completely. Small amounts of metal compounds, turning molten glass into glowing works of art. Silica sand, the primary ingredient in nearly every piece of modern glass, making up around 70% of the entire mixture. This fine industrial sand becomes the foundation of molten glass, processed, filtered, and transported in massive quantities every day. Tiny grains of silica, feeding furnaces hot enough to turn sand into liquid light. Inside the mixing system, every raw material is measured and blended with precision. Many manufacturers guard these formulas closely, helping create the unique colors and character of their glass. Then the batch moves toward the furnace. Separate furnaces are often used to melt specialty glass colors in smaller batches. Automated ladle systems then transfer the molten glass, allowing artists and manufacturers to blend unique colors into the main production process. Not all glass is sent through massive rollers to become flat industrial sheets. In art glass production, some molten glass is taken directly from the furnace while still glowing hot, then shaped, stretched, and worked entirely by hand. Skilled artisans gather the molten material on long, steel pipes, carefully controlling heat, movement, and timing with every rotation. Other pieces are cut into small, colored fragments, later assembled into detailed stained glass designs and decorative mosaics, a process where industrial heat meets human craftsmanship, transforming molten glass into functional works of art. From art to architecture, from handcrafted beauty to endless industrial precision, this is how modern flat glass is made. Industrial flat glass begins with the same essential ingredients: silica sand, soda ash, limestone, and recycled glass. Recycled glass returned to the production line, crushed, sorted, and transported through industrial recycling systems, before entering the furnace once again. Unlike raw minerals, cullet has already been melted before, which means it requires far less energy to melt again. Broken glass, beginning a second life inside the furnace. Unlike smaller art glass workshops, industrial glass production operates on an entirely different scale. Massive conveyor systems continuously transport tons of raw materials every hour, feeding giant furnaces that run day and night without stopping. Along the furnace walls, temperatures already exceed 1,300 degrees Celsius, as the raw batch slowly moves deeper into the intense heat ahead. Furnace operators continuously monitor the chamber conditions, making constant adjustments to keep the molten glass stable and flowing evenly. Inside the furnace, massive burners roar day and night, surrounding the chamber with intense industrial heat. Molten glass now flows like liquid honey, leaving the furnace in a glowing stream. Then comes the float bath, where the molten glass spreads across a river of liquid tin. Gravity and heat do the rest, forming a perfectly flat sheet of glass. But glass is not shaped into flat panels alone. Across another production line, glowing drops of molten glass fall into precision machines, beginning the creation of bottles, containers, and everyday glass products. At the highest level of the factory sits the furnace system, where raw materials are transformed into rivers of molten glass, flowing day and night without interruption. The glowing liquid is then guided through long, heated channels toward the forming floor below. There, synchronized machines cut the molten stream into perfectly timed drops, before shaping each one into bottles within seconds. An industrial process built around heat, timing, and continuous motion. Molten glass drops from the feeder like glowing liquid honey, cut precisely into measured gobs before entering the forming machine. Inside, rows of molds open and close in perfect rhythm. Some bottles are shaped using the traditional blow-blow method, where compressed air forms the glass in 2 stages. Others use the more modern, narrow-neck press blow process, pressing the molten glass first, before the final blow shaping. Thousands of glowing containers move through the machine every hour, each one formed in seconds, while still soft enough to flow like liquid fire. Freshly formed bottles enter the lair while still glowing red hot. Inside, temperatures slowly fall from nearly 600 degrees, allowing the glass to cool evenly, relieve internal stress, and gain the strength needed for the outside world. From glowing molten glass to perfectly formed bottles moving through endless production lines, this is the hidden world inside modern glass factories, a process driven by fire, precision, and machines operating without pause. Yet even inside massive industrial systems, glass still remains something almost alive, shaped by heat, gravity, motion, and light. And long before it reaches our hands, every single bottle has already survived a journey through extreme temperatures, careful engineering, and thousands of synchronized mechanical movements. An ordinary object, born from one of the hottest and most precise manufacturing processes on Earth.